My name is Xiaoyu Cao, a PhD student at Duke University. And today I'm going to talk about my previous work with my advisor, Neil Gong, mitigating evasion attacks to deep neural networks via region-based classification. So as we all know, there are many applications of deep learning in our life now, which makes our life easier. However, when deploying deep neural networks, security can be a big issue. Different types of attacks have been proposed to compromise deep neural networks, including evasion attacks, poisoning attacks, and model stealing attacks. And in this paper, we focus on evasion attacks, which adds perturbation to the inputs at test time to fool the classifiers. And here is an illustration. This image on the left is the giant panda. And luckily, our DNN can also recognize it as a giant panda with a very high confidence. However, when added with this nonsense noise, like shown in the middle, it is misclassified as a gibbon. So with an even higher confidence. So such well-crafted perturbed inputs are called adversarial examples. And what we want is to mitigate the effect of this adversarial example. Several defenses have been proposed, and they can be mainly divided into two categories. One is to find new methods to train a more robust neural network. The other one is to detect adversarial examples. However, they both have some severe drawbacks. So what our goal is to find a way to mitigate adversarial examples while preserving the performance of DNNs. You know, we like DNNs because they have good performance. To do so, we need to first better understand the adversarial examples. We did a statistical analysis and found that most of the adversarial examples lie next to the decision boundary, which means that even if the single adversarial example itself is misclassified, the region around it still contains some useful information about its true label. Thus, we come up with the idea of region-based classification. So in the traditional way of classification, when an input comes, only this single data point itself will be classified by the deep neural network, which we call point-based classification. In this work, we propose region-based classification instead to enhance the robustness against adversarial examples. Here is how it works. So when an input comes, we first randomly sample from the region around this input. And then we will classify each of these random samples using point-based classification. Finally, we will aggregate all the output we get and make our final decision. And here are some experimental results. It shows that our region-based classification can enhance the robustness against adversarial examples without sacrificing the classification accuracy. So that's it. Thank you.